Alright, this is extension number 3 for chapter 1, where I'm going to show you how to find the surface area and volume of a sphere. A sphere really is a three-dimensional, circle or globe. Anyways, recall that the surface area of an object is really the area of its surface. In the case of a sphere, though, the surface is not a flat plane. So how can we find its surface area? Well, let me show you another video, and hopefully that will help you out. Okay, let's watch. Notice that they actually are peeling the nice little orange. That's a nice sphere. They drew the 4 circles of the same diameter, and now they're actually ripping up the peel and trying to fill up the circles. Now, how many circles do you think it requires to fill up? Yeah, 4 circles. So the surface area of that sphere, which was that orange, is really just 4 circles, or 4 pi r squared. From the video, you found that the surface area of the sphere is equal to the area of 4 circles, which happens as a formula to be what? Yeah, 4 pi r squared. That is the correct formula for the surface area of a sphere. Now, another way of thinking about the surface area of a sphere is by looking at relating it to the curved surface area of a cylinder. Now, if the cylinder has the same diameter of the sphere, and the height is equal to its diameter, once again that's why it's 2r, then what you find is that the curved surface of the cylinder is given by what formula again? Do you remember this from grade 12? Not grade 12, grade 8. Remember 2 pi r squared, that's the 2 circles, top and bottom, and then the curved surface is 2 pi r h. Yeah. Now in this case, what we find is that 2 pi, what is my r and what is my h? Well, my r is still r, right? But my h in this case is, that's right, 2r. So that's 2 times 2, which is 4, pi r times r, which is r squared. The same formula here. Alright? So, the video worked. This analytical method worked. They're both the same formula, thank goodness. So, now let's try to actually apply it. So I'm going to ask you to find the surface area of the following figures. In this case, yes, it's just 4 pi. Notice it's r, not the diameter. So take 30.4 and divide it by 2 to figure out r. That would be 15.2. And then don't forget to square. And crunching this on your calculator, I got 2,903.33 centimeters squared. Okay. Now look at what happened in this case. This is looks like a sphere that got cut in half, so this is called a hemisphere. So how would you find the surface area of this? If you thought of it as saying take the surface area of just half of the original, 4 pi r squared. I like that. In this case, r is 2 feet, so 2 squared. Oh, wait. Just checking. R is not 2 feet. R is actually 1 foot. So in this case, that's equal to 2 pi. And if you think that's the correct answer, whoa, careful. Find the surface area. That's all the surfaces you can touch. This 2 pi represents this part here. But you forgot now that I can actually touch this piece that we cut. That surface. So you also need to find the area of that surface. Well, the area of that surface is just another circle with radius 1, so that's just pi 1 squared, or pi. So the total surface area for this hemisphere, because you can touch the top as well, is equal to 2 pi plus 1 pi, which is actually 3 pi, or that's approximately 9.42 feet squared. Okay, so don't forget that top piece there. Tricky. Okay, let's look at example number 2. It says a glass blower is making a crystal ball. She starts with a spherical blob of glass that's 20 centimeters in diameter and blows it up. So something that's 20 centimeters in diameter and blows it up until something that's 80 centimeters in diameter. Now the question is, by how many times has its surface area increased? So really when I ask you how many times, I'm actually asking you for a ratio. The ratio of the new surface area divided by the ratio of the surface area as when you started. So if I look at the starting one, surface area here is just 4 pi r, which would be 10 squared. That's just 400 pi. If I look at this one, the larger one, same formula, 4 pi, but this time, yep, 40 squared. We'll multiply all that out. That gives you 6,400 pi. And so the ratio here is what? Well, the ratio is the new divided by the old, which equals to 16. So it's actually 16 times as big. So I'll say, therefore, the surface area is 16 times bigger. There you go. Okay, to the page. Now let's investigate to see how we can figure out the volume formula for a sphere. Okay, this one's a little bit more tricky. Okay, and I want you to visualize how we can take a volume or create a volume of a sphere. Take a look at this picture here. Okay, visualize a sphere that's covered with very small squares. Okay, these are actually squares. Okay, squares, squares, squares. And each is joined by line segments to the center of the sphere to form a square-based pyramid. And that's that shape there drawn. Now the volume of the sphere really is just the sum of all of these square pyramids put together. Does that make sense? Okay, so what I've just said to you is that the volume of the sphere, so V sphere, is equal to the sum of all the square-based pyramids. Now, how do we actually figure that out? Now, there's a special notation for sum that you might not have seen in math, but it's this like E. It's called sigma. It's a Greek letter. So that's the notation we use to represent the sum. Now, what is the square-based pyramid volume? That, of course, is 1/3 of the base area multiplied by the height. Okay? Now, notice I said here, what is the height of the pyramid equal to? So, what is the height of each of these pyramids? If I'm connecting the edge there to the center of the sphere, that also has a special name. And if you said yes, it's the radius, you are correct. So the height here is actually the radius of the sphere. So I'll call that R. Now, what I'm going to do here is I'm going to take the 1/3 and move it in front and put the sum over here, the sum of the base areas. And times that by the height. I guess I can put height, H, and then I'll say H is equal to R. Now, the question I have for you is, what is the sum of all the base areas of all of these square-based pyramids? If I were to add this piece plus this piece, this piece, this piece, this piece, this piece, this piece, all these pieces, if I add them all together, can you see what I actually get? What is the sum of the base area? Well, that is equivalent to, yes, the surface area of the sphere. And we just calculated that on the previous page. That was 4 pi r squared. So notice that our formula now becomes 1/3 times 4 pi r squared times r. And if I were to put that together, 4 times a third is 4/3. Pi r squared times r is r cubed. So therefore now we have the formula for the volume of the sphere. It's 4/3 pi r cubed. Ta-da! And now I'd like you to try these last two examples with this formula. So find the volume of the sphere. Well, example number 2. Pretty straightforward. Just use the formula. 4/3 pi. R in this case is 12. Oops, don't say 12. Yes, it's 6. Cubed, don't say squared, it's cubed. That's 4/3 times pi times 216, or 288 pi. And remember, this is meters cubed. And if I want to actually find the radius of the sphere, go backwards now. I'll use the volume formula again. 4/3 pi r cubed. That's 100 pi equals to 4/3 pi r cubed. I'll divide both sides by pi. I will divide by 4/3, which is multiplying by 3/4. That's 75. That's equal to r cubed. So r equals to the cube root of 75. And if you want an exact answer, that's approximately 4.22 centimeters. Okay. Alright, last one here. The thickness of an orange peel is 0.47 centimeters. Okay. If the diameter of an unpeeled orange is 7.8 centimeters, what is the percentage of the orange peel? So this is a pretty small orange, 7.8 centimeters. That's okay. I've got my orange. It has a diameter here of 7.8. So of course, if I'm looking at the radius would be 3.9. But notice I have a nice peel that goes around the orange, and that peel has uniform thickness. That thickness happens to be 0.47. So this extra little pit here is 0.47. And so the question I have for you is now, oops, I made a mistake, didn't I? This is an unpeeled orange. Oops, 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 oops. My bad. So here's the peel now. It's inside. And this distance here is 0.47. Does that make more sense now? I hope so. What percentage of the orange is peel? So really we need the volume of the peel and also the volume of the orange, and then we compare for the percentage, right? So let's just look at the entire orange first. The volume of the entire orange. Let's do that first. I think that's a little bit easier. That's just 4/3 times pi r, which in this case is 3.9 cubed. You can punch that into the calculator. I got an answer of 248.48. Now, the volume of a peel is a little bit different, right? Because the volume of the peel is a little bit harder to calculate. It's really the volume of the entire orange minus what? Minus the volume of the actual orange meat, right? Or the good stuff that we eat. I'll call it meat. I don't know what else you want to call it. So to find the volume of the entire orange, we've got that from above. But to find the volume of the meat, we have to actually use the formula 4/3 pi r cubed. Now, what is r in this case for the meat? Well, the r value that we're going to use would be this distance in black, and that would be defined as 3.9, the distance in red, subtract off the thickness of the peel, 0.47. And that's equivalent to the number 3.43. So that is what we're going to use now as the radius for the orange meat. And so if we do this calculation, that's 248.48. I got this as 169.03. So total is 79.45. And you're like, that's great. That's the volume of the peel. But because I said what percentage of the orange is a peel, that percentage is like a ratio. So it's really the volume of the peel divided by the volume of the entire orange. And because it's a percentage, we need to multiply that by 100. So if we take our numbers now, peel, which is 79.45, orange, which is 248.48, and we multiply that by 100, lo and behold, about 32% of the actual orange is peel. So you're only getting to eat actually about 2/3 or 68% of the orange. What a ripoff. I guess that's why some people like orange juice.